Modern civilization often assumes it has surpassed the engineering knowledge of the ancient world. We have satellites mapping the planet, artificial intelligence writing software, and massive infrastructure networks powering entire cities. Yet, when it comes to something as basic as clean water, modern systems can be surprisingly fragile. Pipes burst, treatment plants fail, and entire communities can lose safe drinking water within hours. What makes this reality even more striking is that over 2,000 years ago, an ancient civilization built water systems so resilient that parts of them are still functioning today. The Romans supplied massive cities with clear flowing water using nothing more than gravity, stone, and careful observation of nature. No electricity, no pumps, and no chemical treatment plants. Hidden within these systems was a quiet engineering trick that purified water naturally long before modern filtration technology existed. That method centered on a structure known as the Piscina Limaria, a deceptively simple settling basin that allowed gravity, time and filtration to clean water before it ever reached the city. Understanding how this system worked reveals just how advanced Roman engineering truly was. At the height of the empire, the city of Rome had more than 1 million inhabitants. Supplying that many people with fresh water might seem impossible for the ancient world. Yet Roman engineers built a network of aqueducts capable of delivering enormous volumes of water every day. These aqueducts carried spring water from distant mountains using carefully calculated slopes, so the water could flow slowly and steadily for miles. Instead of forcing water through pipes with pressure and pumps, the Romans relied on gravity. This approach eliminated the need for mechanical systems and created infrastructure that could operate reliably for centuries. At the heart of this design was a system that quietly cleaned the water as it travelled. The Piscina Limaria functioned as a settling basin built along aqueduct routes. As water flowed through narrow channels, it carried sand, mud and debris from the mountains. When the water entered the wider chamber of the basin, its speed dropped dramatically. Once the current slowed, gravity did the rest. Heavier particles naturally sank to the bottom, while cleaner water remained above. The outlet channel was carefully placed halfway up the chamber wall, so only the clearest water continued toward the city. Sediment accumulated in a lower trench, where workers could periodically remove it without interrupting the entire water supply. This passive purification system relied entirely on natural physics rather than machinery or chemicals. Archaeological evidence shows that Roman engineers went even further. In some ancient water systems, researchers discovered containers filled with charcoal, used to absorb impurities and remove unpleasant taste from water. This is essentially the same principle used by modern carbon filters. They also use sand filtration, where water slowly passes through layers of fine sand. This process traps particles and encourages the growth of a biological layer that naturally breaks down contaminants. Although the Romans did not understand microbiology, their careful observations, allowed them to build filtration systems that significantly improved water quality. Ventilation shafts were also added to aqueduct tunnels, allowing fresh air to circulate and helping maintain the clarity and taste of the water. Together, these elements formed a surprisingly sophisticated purification system. Many Roman aqueducts remain standing after nearly 2,000 years. Structures such as the Pont du Gard and the Aqua Virgo, which still feeds the Trevi fountain, really demonstrate the incredible durability of Roman engineering. A major reason for this longevity is Roman concrete. Builders mixed volcanic ash with lime to create a material that could actually repair itself. When cracks formed, water triggered chemical reactions that filled the gaps with new mineral crystals. This self-healing process, honestly, helped Roman structures survive centuries of environmental stress. Despite its effectiveness, much of this engineering knowledge disappeared after the fall of the Roman Empire. During the Gothic War, invading forces damaged the aqueducts supplying Rome. Without a stable government or trained engineers to maintain them, the systems gradually fell into disrepair. Over time, the techniques used to build and maintain these purification systems, well, they faded from memory. For centuries, much of Europe relied on wells and rivers that were honestly often contaminated. Ironically, many modern water treatment methods were rediscovered long after Rome had already demonstrated their effectiveness. Today, engineers are beginning to revisit the principles that made Roman water systems so resilient. Instead of relying solely on high-pressure pipelines and energy-intensive treatment plants, some cities are, incorporating natural purification methods such as wetlands, stormwater gardens, and passive filtration basins. These systems slow water down, allow sediment to settle, and let natural biological processes help clean it. Exactly the philosophy Roman engineers used 2 millennia ago. Roman water systems remind us that great engineering does not always rely on complex machinery. Often it comes from understanding natural processes and designing systems that work with them rather than against them. By slowing water, allowing gravity to settle impurities, and using natural filtration, Roman engineers built infrastructure that, quite remarkably, outlasted the empire itself. As modern cities face aging infrastructure and environmental challenges, the lessons hidden in ancient Roman aqueducts may be more relevant than ever. Sometimes the future of engineering begins by rediscovering the wisdom of the past.